Earlier we have learned how an electric current is induced by the relative motion between a closed coil and a magnet. Electric currents can also be induced in a closed coil by causing a change in the magnetic flux, produced by its relative motion with another current-carrying coil in its vicinity, or by a flux change produced by the same coil. Let us first understand the experimental setup that helps us demonstrate this phenomenon. The coil on the left is called the primary coil and is connected to a battery. Let the current in this coil be I1. The coil on the right is called the secondary coil and it is connected to a galvanometer. The primary and the secondary coils are placed coaxial and an iron core runs along the axes of the coils. Let P be the magnetic field strength due to the current in the primary coil. When the secondary coil is moved towards the primary coil, the magnetic flux through the secondary coil increases. As a consequence of the increasing flux in the secondary coil, the current induced in it increases as it moves towards the primary coil. Let the current induced in this coil be I. When the secondary coil moves away from the primary coil, the magnetic flux through the secondary coil reduces. As a consequence of the decreasing magnetic flux, the current in the secondary coil decreases. The magnetic flux in the secondary coil, phi b, is directly proportional to the current I in it. The variations of the current in the secondary coil are directly proportional to the variations in the magnetic flux. Thus, the rate of change of flux is directly proportional to the rate of change of current. Let the number of turns in the secondary coil be n. Hence, the net flux change in the secondary coil, n phi b, is directly proportional to I. The term n phi b is called flux linkage. The constant of proportionality m between the flux linkage and the current is called the mutual inductance of the coil. Inductance is a scalar quantity and has the dimensions ml square t power minus 2 a power minus 2. The SI unit of inductance is Henry, named after the scientist Joseph Henry, and is denoted by H.